Just a quick introduction to the types of drone, and I'm sure you're all quite aware of the different things, different types. So there's a fixed wing. It looks like a standard aircraft where you've got the propulsion to drive the motor forwards, the fixed wing giving you the lift. On the right there, we've got what we see as in a lot of the arena as drones now, where you've got a multi-rotor, quadcopter, hexacopter, and then in the middle you've got something that combines the both, where you can have a fixed wing drone that is capable of vertical takeoff and landing. So the fixed wing is good for long range, high flight speed. It's not particularly manoeuvrable, but then the multi-copter dynamic flight is brilliant. Can take off and land in with no space, can carry some high payloads. And the VTOL sits there in between, so it takes the best parts of both and combines them. So first and foremost, on your drone, we're looking at propulsion. So all these drones now that are coming on, they're the battery powered. We're looking at an efficient drive system. It's not just the motor as such that needs to be efficient. You've got to look at it as an overall propulsion package. So that includes your motor, your motor controller, and also your propeller. So you've got to match them all up to get your most efficient drive system. Your propulsion system really is specified for what you need to do for your flight requirements. If you're using a multi-copter, you've got to have sufficient thrust there from your 4 or 6 motors and propellers to lift your drone and the payload as well that you're carrying. And then on the fixed wing, you need sufficient thrust to get through takeoff. And then once you get into forward flights and you're flying, then you can really ease back on the power for your long duration. Very much the same for all. It's looking at an efficient system. Then we'll go on to flight surface actuation. So this is more on the fixed wing aircraft. The ailerons, elevators and tail will all need to actuate. There's various different options you can use from your radio controlled servos, readily available from your shops. And then the top right there's some more specific aircraft or airspace qualified servos on the market. And then sort of something that we can do as Maxon is we can do some linear actuators where you've got motor gearbox and ball screw. What you use or what drone manufacturers are using is very much dependent on their specification criteria, for space envelope, safety requirements, and budget as well. If you start looking at qualified products, then there's costs associated with that. And then you're down to your mission, so your payload. So what are you doing with the drone? Are you looking at some form of imaging, scanning system? Have you got a camera on there or a LiDAR system? In which case you'll have something like the top right there, where you'll have a motorized gimbal which is stabilized to compensate for the vibrations in the drone. Each axis in that product will have a motor in there just to provide the stabilization. And if you're doing a delivery system, how do you let what you're delivering leave your drone? Do you land, or as with a company that we've been working with, looking at deliveries, actually winch down the package so the drone stays in the sky and keeps the spinning propellers away from the public when they are delivering. So it's looking at what you need to do with the mission that you're developing your drones for.